Hello and welcome back to another video. In this one we'll be talking about second order differential equations. More specifically, non-homogeneous differential equations, and we'll take the undetermined coefficient method. Now, the second order non-homogeneous equation looks like this. Well, ay double dash plus by dash plus cy is equal to a function of x. Now, how do we get a general solution for that equation? Well, the general solution is made up of two parts. So we have y is equal to yp plus yc. Yp stands for particular solution, and yc is the complementary solution. Yc is exactly the same as the same solutions as we used to do for the non-homogeneous equation. If you haven't checked out the videos within this playlist, I suggest you go back and see it to understand it more. Now, how do we get yc? It's based on the value of the roots, because when depending on the values of the roots, we get different general solutions. Yp, on the other hand, depends on the value of the function of x here. So we have three different solutions, or three different possibilities. If f of the x is equal if f of x is equal to a function of x, so for example, if we have 1, 2, -1 x squared, as long as f of x does not equal an exponential or a trigonometric function such as cosine x, our general solution, or our particular solution, yp, is equal to ax squared plus bx plus c. Now that would be a particular solution. Obviously, when we do more examples, it becomes more clear, because we have to derive the equation here and substitute our values in our equation, second order equation, so we get the values of a, b, and c. If the second one, if f of x is equal to an exponential value, for example, k is a constant number, and cx, also c is a constant number, then our particular solution would be a exponential cx, where c is a constant number and we have to find a. Now, if our f of x is equal to a trigonometric function, for example, it's equal to cosine x, our particular solution would be c1 cosine nx plus sine plus c2, let me just fix that, c2 sine nx, and that would be our three different possibilities. To make these videos short and to keep them short, we'll concentrate on the first possibility first, so we'll do exercises for them in this video. Then later on I'll upload the part 2 for the second possibility and the part 3 for the third possibility. Now we'll move on onto an example. So we have this example: y double dash plus y minus 2y is equal to x squared. Our first step is to find the second degree equation to find the complementary solution. So we have r squared plus r minus 2 is equal to 0. We'll use the brackets method as it's easier. So we have r and r, it gives us r squared. We have a positive multiplied by a positive is a positive by a negative is a negative, and two numbers that multiply to give us negative 2 and add up to give us plus 1 is 2 and 1. So we have r1 is equal to negative 2 and r2 is equal to 1. So our complementary solution yc is equal to c1 exponential r1x plus c2 exponential r2x. So now we have the complementary solution. We must find the particular solution. So yp is dependent on the value of f of x. Since it is not a exponential value or a trigonometric function, particular or particular solution is a x squared plus bx plus c. Now we must derive yp twice to give us y double dash and y dash, and y dash. Therefore we have y dash would give us 2ax plus b, and y double dash would give us 2a. Now we substitute them back into our differential equation to find the values of a, b and c. So we have 2a would give us y double dash will have 2a plus 2ax plus b minus 2 multiplied by ax squared plus bx plus c, and obviously that is equal to x squared. Now we have 2a to simplify even further, so 2ax plus b minus 2ax squared minus 2bx minus 2c is equal to x squared. Now we have one term with x squared in it, so we have here, so negative 2ax squared is equal to x squared. We divide by negative 2x squared. We get a is equal to negative half. Since we have a known, we can calculate the others. So we have the other terms. We have 2ax and negative 2bx. So we have 2ax minus 2bx is equal to 0, and we divide by x or 2x. We get a minus b is equal to 0, and we have half, negative half, minus b is equal to 0. We move the half to the other side. b is equal to negative half. Since we move the half to the other side, it becomes positive half, and we divide by negative 1, we get negative half. So, and to find the value of c, we have 2a plus b minus 2c. So we have 2a plus b minus 2c is equal to 0. So we have 2 multiplied by negative half plus negative half minus 2c is equal to 0. So we have negative 1 minus half minus 2c is equal to 0. We have negative 3 over 2 minus 2c, which is 0, equals to 0. So c is equal to 3 divided by 4. Now all we have to do is substitute our values of yc and yp into our general solution. So we have y is equal to yc plus yp. So we have yc is c1 exponential negative 2x plus c2 exponential exponential x, since r2 is 1. Now for yp, so plus, we must substitute the values of a, b and c into this equation. So we have negative half multiplied by x squared plus negative half multiplied by x plus 3 over 4. So our final yp would be x squared divided by 2. So that's minus x squared divided by 2 plus, sorry, let me fix that, would be minus x divided by 2 plus 3 over 4. So we take that equation and we put it here. So negative x squared divided by 2 plus, sorry, minus x divided by 2 plus 3 over 4. And that would be our final answer. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful. Thank you.